Hello everyone. Right now I'm doing Lab 4 Part 1, which is the stepper motor controller. So for this part, we are required to develop a more state machine that will provide this sequence of signals under the control of three inputs, which is EN, the enable stepping, the CW controls the direction of stepping, and also clock for the state machine. And from this stepping sequence, we have managed to get our state diagram. It goes like this. Only when EN and CW is 1, it'll go to the next state in a clockwise direction. But if EN is 1, but then CW is 0, it'll move to the next state, but in a counterclockwise direction. And from the state diagram, and with the help of flip-flop excitation table, we have managed to fill up our table like this. And from this table, we have managed to fill up our K-map, and we have gotten our equation for JB, KB, JA, and as well as KA. And also from the help of the table behind, we have gotten our output functions for the four output functions. Sorry. And from the K-map and also the equation of output functions, we have managed to construct our schematic diagram, which goes like this. And by using this schematic diagram, we have also managed to construct on the board. So, according to our prediction here, when EN is 1 and CW is 0, it will move to the next state but in a counterclockwise direction. But if CW is 1, it will move to the next state but in a clockwise direction, as you can see here. But let's say when EN is 0, it won't move to any state. Doesn't matter if CW is 1 or CW is 0. And it's exactly like our prediction here. So thank you. Yeah. So right now we're doing Lab 4 Part 2, which is the linear feedback shift register. And this is the circuit that we have drawn. And our XO is connected to Q2, and our X1 is connected to Q1. Okay, and this is what we have constructed on the board. And the question asks us to check whether the operation goes as our prediction, because which goes like this, repeats itself. Okay, whether it's a random bit or not. And this is what we get on the oscilloscope. And as you can see here, there's a sequence here which is exactly like this one, the XO. It has the same sequence on the oscilloscope. So does it appear random? No, it does not appear random. Okay. Alright, that's all. So right now we're doing the second part of Part 2. The question asks us to modify our circuit to the equation as follows. And we have changed our XO to Q5, which is pin number 12. And our new X3 is Q3, which is pin number 6. And after that we have constructed our circuit on this board. And the result is like this on the oscilloscope. It appears random, as you can see here, except for this part and this part. Is that all?
Yeah, because it's 0 and 1.
because it's 0 and 1.
Yeah. So yeah,
That's it.
that's it. Okay. Alright.
So right now we're doing lab 4, part 3. So for part 3, we are asked to design a multi-state machine to detect the sequence of 0, 1, 1. And this is the state diagram that we have constructed. As you can see here, from 0, 1, the output F will be 1, and it detects 1 as it will become 0, 1, 1. And that's the only time when F will have a 1 output. So we have constructed our schematic diagram. Our W we will take from XO from part 2, part 2B actually, and yeah, and so this is how our board looks like, and this is what we get on the DO, the oscilloscope. Already run, stop. So as you can see here, when it's 0, 0, 1, 1, the output here will become 1, and also here 0, 1, 1, the output will become 1, and like this one, when it's 0, 1, 1, the output F will be 1, and that's it.